Welcome to the class. In this video, I'll give you some hints and solution to you on miscellaneous exercise based on chapter number 5. So let's get started. Question number 1 is differentiate with respect to x. 3x squared minus 9x plus 5 raised to the power 9. So in this case, we'll take this as t and use chain rule. Question number 2. In this case also, we'll use chain rule. We'll have two separate derivatives. We'll differentiate this with respect to x. The derivative will distribute among these two. Then we'll make use of chain rule. It will be sin x whole cubed plus cos x whole cubed. So in the first case, we'll take this as t, and in the second case, we'll take cos x as t. Now question number 3. The function is variable raised to the power variable. This is a variable and it has got the variable power. So where there is variable raised to the power variable, we have to take log. We'll take log in this case. So log of y will be equal to log of 5x raised to the power 3 cos 2x. Using property of log x to the power y is equal to y log x. It will be 3 cos 2x into log of 5x. This power will come before the log. Now we will use product rule. This is the first term and this is the second term. In both the cases, we will use chain rule again, so we can easily solve it. Now question 4. So here we have two options. Either use chain rule or use the method of implicit function. For implicit function, we can write it as sin y into x root x, then differentiate. Directly we can take x root x as a t, x root x as t. So this will become sin inverse t. Find the derivative of this with respect to x. So d over dt of sin inverse t into dt over dx using chain rule. So you have got two methods, whichever you like you can use. Now question number 5. Here we can use quotient rule and then chain rule. So this can be done easily. Now question number 6. Inside the bracket, we'll multiply both numerator and denominator by the conjugate of the denominator. So we'll get y equal to cot inverse under the root 1 plus sin x plus under the root 1 minus sin x whole squared divided by 1 plus sin x minus 1 minus sin x. What we have done is we have multiplied both numerator and denominator by the conjugate of denominator. Y is equal to cot inverse 1 plus sin x plus 1 minus sin x a square plus b square plus 2ab plus 2ab, the product of ab. In denominator 1 will cancel 1 and we'll have 2 sin x remaining in the denominator. Simplifying the numerator, will get y is equal to cot inverse. This sign will cancel this sign and we'll get 2 plus 2 under the root. This will become cos square x. This will become cos square x, and the square root of cos square x is cos x. So we'll have 2 cos x divided by 2 sin x. In next step, 2 will cancel 2 in both numerator and denominator. So cot inverse 1 plus cos x divided by sin x. Using cosine formula in the numerator, we get cot inverse 1 plus 2 cos square x by 2 minus 1 divided by 2 sin x by 2 cos x by 2. Now this will 1 cancel this 1. After that this 2 will cancel this, and this cos x by 2 will cancel 1 power of cos square x by 2, and we'll have cot inverse cos x by 2 divided by sin x by 2. This is the value of y. So y is equal to cot inverse cot x by 2. Y is equal to x by 2. Now differentiating both sides, dy over dx is equal to 1 by 2. This is very important problem. Now question number 7. Wherever variable power variable is there, you have to take log. So log y is equal to log of log x raised to the power log x. So log y is equal to log x into log of log x. Now first we will use the product rule, then we'll use chain rule here and here. Question number 8. Question number 8 is cos of a cos x plus b sin x for a and b are some constant. So we'll use chain rule. First we'll take this as t, and then we'll differentiate t with respect to x. Then ninth one, sin x minus cos x. So let this be y taking log y is equal to, this power will come before the log, so sin x minus cos x into log of sin x minus cos x. Then proceeding further, here we'll use chain rule, here we'll use product rule first, and then here we'll use chain rule. Question number 10. Keep in mind that log function is not distributive. Log function is not distributive, so we cannot directly take log on both the sides, first thing. And moreover, we have to take log only for the first term because it has got variable raised to the power variable. For others we have the formula. This is similar to x raised to the power n, variable raised to the power constant. We have the formula for this, d over dx of x raised to the power n. Similarly, a raised to the power x, we have again formula for this. And the last one, a raised to the power x, constant raised to the power constant is constant, so the derivative of this will be 0. So this is variable raised to the power constant. We have the formula for that. It is similar to x raised to the power n. D over dx of x raised to the power n is x raised to the power n. We have the formula for that. Similarly, we have formula for this also, constant raised to the power variable. And last one, constant raised to the power constant means constant again. Its derivative will be 0. Then question number 11. So here also both the terms have variable raised to the power variable, so we have to take log for both terms. So let u is equal to x raised to the power x square minus 3, and v is equal to x minus 3 raised to the power x square. So taking log separately, log of u is equal to x square minus 3 log x. Same way here, log v is equal to x square into log of x minus 3. Then using product rule and chain rule, we can find du over dx from this side and dv over dx from that side. Finally dy over dx will be du over dx plus dv over dx. This will be our answer. Question number 11 is, here it is a parameter. First we'll find dy over dt, then we'll find dx over dt. Then for dy over dx, we'll divide dy by dt by dx by dt. Now suppose you have to find its second order derivative. So from there, we'll again differentiate this. d2y over dx square is d over dx of dy over dx. 13. For first term, we can directly use the derivative of sin inverse x. And for the second term, we have to use the chain rule. And now the 14th one. So here we have given x into 1 plus y into under the root 1 plus x is equal to 0. We'll transpose this to the other side. Now we'll have x into under the root 1 plus y is equal to minus y into under the root 1 plus x, squaring both sides. We'll get x square into 1 plus y square into 1 plus x. Simplifying, x square into x square y equal to y square into x y square. Transposing all to the same side. X square minus y square plus x square y minus x y square equal to 0. Factorizing. From first two we have x minus y and x plus y as factors. And last two will give you xy into x minus y equal to 0. Again x minus y is common in whole of the expression. So we'll get x plus y plus xy is equal to 0. Now the product of two terms is 0. So at least one of them should be 0. If x minus y is equal to 0, then it gives you x equal to y or y equal to x. Then finding derivative dy over dx is equal to 1, which is not to be proved. It means that x is not equal to y. It means that x is not equal to y. It means x plus y plus xy is equal to 0. So y is equal to x plus, taking y common from the last two terms, y into 1 plus x equal to 0. So y is equal to minus x upon 1 plus x. Differentiating with respect to x, dy over dx is equal to, on the right side using quotient formula, 1 plus x into derivative of minus x minus numerator into derivative of denominator divided by square of the denominator. Now the denominator will be 1 plus x into minus 1 plus x into 1 divided by 1 plus x whole square minus 1 minus x plus x divided by 1 plus x whole square. So dy over dx will be equal to minus 1 over 1 plus x whole square, which is to be proved. Now we'll solve question number 20. Using the fact that a plus b equal to sin a cos b plus cos a sin b and the differentiation, obtain the sum formula for cosine. That is, you have to find the formula for cos a plus b. Let us suppose, let a is equal to x and b is equal to y. So the formula for sin x plus y will be sin x plus y is equal to sin x cos y plus cos x sin y. Differentiating with respect to x, differentiating with respect to x, we get cos x plus y 1 plus dy over dx using chain rule. On the right hand side, we'll use product rule. Sin x into derivative of cos x minus sin y into dy by dx plus cos y, derivative of sin x is cos x, and similarly for the second term, cos x into derivative of sin y is cos y, and then derivative of y with respect to x, dy over dx plus sin y into derivative of cos x is minus sin x. So rearranging, we get cos x cos y minus sin x sin y plus cos x cos y dy over dx minus sin x sin y into dy over dx. It can be further simplified. Cos x cos y minus sin x sin y, cos x cos y minus sin x sin y into dy by dx, taking cos x cos y minus sin x sin y from the whole of the right hand side, we get 1 plus dy over dx. Now compare left hand side and right hand side. Left hand side is cos x plus y into 1 plus dy over dx, cos x plus y into 1 plus dy over dx. Now 1 plus dy over dx can be cancelled from both the sides. We get the required expression cos x plus y is equal to cos x cos y minus sin x sin y. This is the required expression. Last 22nd question. Question number 22. If y is equal to fx gx hx lmn ab c, then prove that dy over dx is equal to f dash x g dash x hx s dash x lmn ab c. So let us prove it. The definition of derivative is limit h tends to 0 fx plus h minus fx divided by h. Using the same definition, we'll calculate the dy over dx for the given function. Now limit h tends to 0 fx plus h g x plus h x plus h. Now this h and this h are different. L m n a b c minus fx plus h minus fx minus the same divided by h, applying the definition of the derivative, is equal to. Now we'll use property number 5 of the determinant here. So using this property, we'll get limit h tends to 0 will remain as it is, 1 by h equal to fx plus h minus fx gx plus h minus gx x plus h minus hx. Second row and third row will remain same. L m N, A, B, C. This H we can divide either first row or second row or third row, or we can divide first column, second column, or third column, anyone. So we'll divide first column. We'll get limit h tends to 0, fx plus h minus fx divided by h, gx plus h minus gx divided by h. Similarly, hx plus h minus hx divided by h. Second row and third row will remain same, A, B, C. Now, as we know that limit is distributive among all cases, so this limit will distribute in this and this and this also. So, as by definition, the first term of the first row will become f dash x. Second term of the first row will become g dash x, and third term of the first row will become h dash x. L, M, N, A, B, C. This is the value of dy by dx, hence proved. So this much only in this video. In our next video, we'll learn the rate of change of quantities under application of derivative. Until then, keep learning. Thank you.